Welcome once again. Just to continue with the properties of waves, that is Physics Book 3, we are going to look at refraction of waves. And we all know that refraction is the bending. So this is the subtopic, the bending of waves as they travel from one medium to another. So as waves travel from one medium to another, then they have to bend. And it is good to note that the speed of waves changes from one medium to another. So in this case, we are going to change or to consider the behavior of water waves. So we can see that water waves change in speed when they move from a deeper region to a shallower region, and vice versa. So it might be moving from shallower to a deeper region. So in that case, because the regions are different, then we will have the water waves bending. So it is good to notice that the water waves increases as the wave moves from a shallow to a deeper region. From a shallow to a deeper region, the speed of water waves increases. The inverse is true. We will say that water waves decrease in speed when they are moving from a deeper region to a shallower region. So it is good to note that, for example, the case of water waves being produced from a ripple tank, it is good to know that if the source of the water waves is remains constant or maintained, if it remains constant, then we can conclude that the frequency of the waves is uniform in either medium. So if we have water waves moving from a deep region to a shallow region, or from a shallow one to a deep one, and the production of the waves is the same, then in both media the frequency remains a constant. The frequency f remains a constant. So when the frequency f remains a constant, then this means that from this equation we have already said that the speed increases. We want to justify that. So we know that velocity equals to f times lambda. Therefore, if the frequency is constant, then increase in speed will lead to increase in the wavelength. Therefore, because water waves are moving from a shallow region to a deeper one, and we are saying in the deeper one the speed increases. So if the speed increases in the deeper region, it means increasing the speed, maintaining frequency at constant. This wavelength will also increase. That results to a conclusion that when water approaches a deep region from a shallow one, then in the deep region it moves with a larger wavelength. So if we have to draw it like this, let's say we have a media there, then this one is a deep region, and this is a shallow one. Shallow region. Then we have water waves here approaching the other yes. So with the water waves approaching this deep region like that, the speed will increase in the deeper region, as we have said. And when the speed increases, automatically the wavelength increases. And now in the deeper region, the wavelength becomes greater. Therefore, you'll find now the wavelengths or the wave trends are now more spaced. Find that the wave trends are more spaced. So, okay, we can have the three just being compared. So when the three cross over to the deeper region, you realize now the wavelength now has become greater compared to the wavelength in this other case. So the wavelength is very small in the shallow region and very wide in the deeper region, because speed increases in deeper region. Speed increasing and the frequency remaining a constant, then the wavelength has also to increase. If we relate the other way around, from a deep region to a shallow deep region, then we will have, if these are the wavelengths, which are a bit spaced, and you are told to draw, this is the boundary between the deep region and the shallow one. You are told to draw the wavelengths after they exit or they enter the shallow region. So the wavelengths will now be a bit squeezed together. The wavelengths increase, the wavelengths reduce. In the deeper region, they are closer to one another because the wavelength has decreased. The speed goes down, and because frequency is constant according to that equation, then the wavelength has also to become small. So that is the relationship when water waves are bending from a deep region to a shallow region. So sometimes we make this the boundary between the two regions. So we can have the boundary like this. Then this is a deep region, and this is a shallow region. This is a shallow region. Then we have the wave fronts. The wave fronts approaching this boundary. so that they be bent now towards the other side. So here we have a wave train, which is a head boundary like that. So what we do is that we go to this boundary, a normal to this boundary, like that, a normal to that boundary like that. Then now these waves now will follow it. So they will bend, but their wave will travel as this normal. So we will say the refracted wave now will go in the direction of this normal. So if we draw a normal to that boundary, and now we will have, because it is from shallow to deeper, to a deeper region, now the wavelength will be bigger, so we will have them now more spaced. We'll have them now more spaced. We'll have the waves exiting when they are more spaced. They will exit when they are more spaced. Like that. So that is how they exit. They get refracted and exit in that design. We can have a representation from a deep to a shallow region, how they bend. So if this is a region, then we have waves. We have waves approaching this boundary. What we will have is the wave train hitting the boundary at that angle. So we are trying to finish this diagram and show how they get refracted into the other region. This is a shallower region, which means speed will go down and hence the wavelength will become smaller. Therefore, we can draw a normal to this boundary. A normal to this boundary. So this normal now to that boundary becomes the wave train. The direction of the wave train is that one. And now because it is to a shallow region, they are smaller. Therefore now the waves will exit when they are more squeezed. They will exit when they are more squeezed than in the other case. So that is how we get the waves refracted from a deep to a shallow region, and this is from a shallow one to a deep one. So that is what we call refraction of water waves. Refraction of water waves. So thank you for following. Kindly subscribe to Shifting Grids. Thank you.